So, hello everyone. I'm really happy to be here today because some members of the review board are my hero, and I will try to not disappoint them and also not to disappoint you as well. This is the history of the Honda Civic. My target is this one, the white one. It's the third gen Honda Civic, so it's 1985 Honda Civic. It's also known as the Wonder Civic because it's quite rare, and it's 100 horsepower for 700 kilograms, so it's quite efficient. The power to weight ratio is very good. What I wanted from this car is to get some more horsepower, but there is not so much solution because there are no programmation things. There is not as much of documentation too. And the solution came to be E85 run, so ethanol run, and using the Honda PGM-FI. So I will go through very fast through these two parts, the E85 build and the Honda PGM-FI presentation, because after this I will come to the true hacking things, which mean I try to plug my keyboard to my car, and some odd things happens. I will not talk about CAN bus because there is no really CAN bus on this car. There are also no OBD, so no OBD port. It came later to be OBD 0, but for this version it's kind of OBD-ish things, but the standard is not actually existing. And I will also not talking about more conventional car hacking things because here the playground is quite limited. So, why I did want to run on E85? There are some disadvantages of running E85. It's quite more corrosive than unleaded fuel. It's also less lubricant, so it harms your engine. But the energetic efficiency is quite higher, so you can run faster by building a car running on E85. Today's the ECU running E85 is just an intermediate ECU which get information from various sensors and then regulates the fuel injectors. Honda come with one solution in the early days. I think they were the first to get this kind of electronic in cars. I'm not sure, but I'm pretty sure they are the first. This came from Formula One. At an era, they are still winning in Formula One. And it's basically managing injection through electronics. This wiring here, I think, is not right because there are no line coming from the injector to the ECU. So I think this one is wrong. The PGM-FI system is still used today in quite all Honda cars, motorcycles, and also lawnmower. Don't know if you have seen this one, but they are running a VTEC engine on lawnmower. So this is the fastest lawnmower in the world. The Honda PGM-FI is managing fuel injection by controlling the time the injectors still open. So it should be something easy to run E85 on a Honda car because the system is already existing, you know. And running E85 has quite of advantage. It's cheaper fuel. Especially in France. It's environmental, also friendly, because it emits less fine particles. And, yes, you can get horsepower. Why pre-OBD? Do you know what OBD means? It's just onboard diagnostic. So it's some kind of system that bring you information on the running state, the health of the engine. And it came as a standard. But at these days, there were no standards. And it's kind of OBD. You get some diagnostic things. I don't know if we see it, but there are some LEDs who throw you messages on error during the engine run. And there is also logging capabilities. From those who are familiar with the OBD2 port, you got this kind of device which called ELM327 and an app like torque to get the RPM, your lap time, and so on. So it's basically some data logging. And this is the part I want to get on my car because I'm running on track day 2 and I wanted to know if my engine is still running well or not. And there is some port. We can't see it here. Yeah. I'm sorry. It's CN3 port. It's a debug port. It's basically a serial port, mostly UART, and you can get data logging on this port. It exists on modern engine, modern Honda ECU, but it's not documented on this one. This is the P7 ECU, which is a 1985 ECU, and to my knowledge, no one has looked inside this ECU, even in data logging or in map changing, because your engine is running maps, and this is on these maps we will interface to change the fuel injection. So I try to get my keyboard, this one, very interesting one, talking to my car. Why I choose this one? It's because it has this screen, this fancy screen here, and this screen should be running some kind of ARM target. I just look on the internet, and there are also UART ports, so serial port. Maybe I can just plug in directly to my CN3 port and get some data logging, writing a fancy interface, and then getting my data log on my keyboard. They have got also some kind of SQL injection on their website. If you have downloaded any of the Mad Catz firmware lately, they may have been backdoored because of this vulnerability. They are aware of it. They told me that it will be patched with a new version in October, so it should be fine. I will go very fast on the firmware analysis things because we know this kind of target. It's an EMX target here. There is some software available online. There is the firmware data available online. So I grab this firmware data, run a small binwalk on it, and you get the entire file system. You can analyze it, modify things, repack it, and push it back again. The flash procedure to get the GFU mod is also documented. So there is no big challenge here. It's quite common. You can get all the information. But what I need here is just to disable all the Mad Catz software because I don't need it. I just only need the USB management or the console port management. There is 2 videos here. I will put my slides online later, but the first one is a short version. The second one is the longer version with some reverse analysis of Qt app, getting some information on UDEV rules, and so on. I will just show you the short version. This target here is running a Qt app, and when it starts, it's globally just start some mapping using the keyboard map, some bulk USB, and then it starts the Qt app, and yeah, it should work. So what I need to do here is just to disable all the Mad Catz softwares, and I should get some kind of console to interact with. This is the init script, and we can see on this init script that the last task this script is doing is the starting of the Qt application. So let's try to just comment this part and start it again. I did not do this because I discovered some more strange things by looking on this special target. The USB port on the keyboard looks like mini USB. And yeah, no, it's not really mini USB. There is a USB cable I open on the right, and I never seen some USB cable like this one. There is a lot of wires. So it's quite strange, you know. This keyboard allow you to have a macro button, and I think some of these lines are serial lines which are mapped to the screen. The USB port, the difference is on, oh, I'm sorry. On the right, you have this part here, down there, which not exist in any other mini USB cable. So I just put this apart from now, because, yeah, you know, this is not so difficult. There may not be so much challenge here. Just, yeah, you know, cut the USB cable, figure out which lines are data lines, VCC, ground, and yeah, it should work. But the process I don't know at this time is a process called UCU chipping. The UCU chipping is quite common on all Honda cars. Even today, there are UCU chipping. The UCU mostly used is the P28, but I don't want to get to the P28 because, to my knowledge, nobody has worked on this one from now. And as it's not OBD, there is not so much documentation on this. So the UCU chipping is the process of removing an external ROM, mostly external ROM. You can also get internal, but on P28 and more modern UCUs, there are external ROM. Just unsolder it and get one you can program and put it back. This special one is not programmable. So I need to, yes, unsolder it, get a socket, find out another chip. We will look at it later, but it's quite difficult because these chips are not available. And yeah, there are no information at all on this device. There is a forum which is PGM-FI by Grassroots, and these guys have done amazing work on all Honda cars. They have a dump of almost all Honda cars since 1980, and they work. They are all tested and they work. So I find someone who has done the dump process. This is not the most difficult process here, but this ROM is a mask ROM. Think mask ROM as ASIC for ROM. You have just this is the processing of etching, which gives this name of mask ROM. So it's a ROM. It's read-only. You can't program it. It's old ROM, so you don't have much of information on this one. I asked someone who is specialized on this process of UCU chipping, which called iFluid, and he told me, I don't know anyone who has worked on this. So you have to figure out by yourself how to use this ROM and how to swap the ROM. I asked Handout too, and they did not come back. So I decided to do it by myself and to validate the data or the right one, I ask a local tuner to read the maps I'm extracting. And the first map I dump, which I have sent to him, it's just not great because, I think I burned the ROM with airflow, and I'm not. It's quite messy. So I used as a reference the ROM I extracted from PGM-FI. This is the process of dumping. There are some caveats on this process. We'll come to this after. I use the Mini Pro. I don't know if you know this one. It's a TL 866 programmer, and I choose especially this one because it's run on Linux. So you have a lot of targets on this one. Quite almost all targets you will encounter, and the process of dumping is not really interesting. I just burn my RAM, so okay, you have messed up. You need to get something to refer to, and I choose to trust the guys of PGM-FI. And when looking at my dump, I'm sorry, this is out of the screen, but when looking at my dump, the head of the dump I have done and the head of the dump I found from the internet are the same. So I guess it should work. It was an epic fight because on this special ROM there are kind of no datasheet at all. This is the only one I found out, and it's quite different from the one I'm using actually. So I need to get some more information on this ROM. I've messed up one time. I don't want to mess up a second time, so I try to get more information, and by looking at this information, I just found this post, which says there are some batch of your ROM which are misstamped. So it should be 128 kilobits memory, and okay, the manufacturer has just misstamped some of them, and they are 256 kilobytes memory. So I was kind of lost here. I don't really know what to think, because the memory I got from internet is also 256 kilobits memory. This post says, you may have a ROM of 256 kilobits, but mine, the dump I have done, is only 128 kilobits. So I need to do some more OSINT and to get through this problem. I finally find out on the same forum someone who has a very special map. It's a map from Honda, the race team of Honda. It's a map from the group N, so it's a race car. And it's from my ECU, P7, so it's good. And they say it's split in two, memory of 64 kilobits. So come back to my first guess, which is 128 kilobits. Okay. But when I look at the schematics, it's quite different from the one I have, and they have split the memory in two parts and use an address decoder. So for those who don't know who address decoders are, it's just a mechanism to speak to multiple memories and to address, to map these memories to the internal state of the CPU. So, okay, I just have to concatenate them, I guess. So I use DD, and I take the first one, the second one, and glue them together. And this did not work. I can't open them in my software, which is on data, but I sent them to my tuner too, and he can't open it. So I may have done some mistake somewhere. And when you are using address decoder, you have to add +1 to the last address of the first memory. And I just missed this +1. So I make another dump, and I just add this +1, and I send this dump to my tuner. He can open it, and I can open it in on data too. So everything's good. Why I did use this special map? It's because when I look further to the process of data logging on the ECUs, you need to add a snippet of code to your map to get the data logging work. Without this code, you can plug on your serial port, you will have no data. And on this map, there is data logging by default. So I will try to reconstruct this one so I don't have to reverse the code, because it's 8085 architecture, and I really don't know this architecture, and I can't get documentation on this one. So when I glue things together, I succeeded into getting some maps. This is a map. You may have seen some of them somewhere before. It's a map who runs your engine. It's basically ratio, air and fuel ratio, among the RPM. So this is it. I can read it. It should work. When I plug this to my car, some odd things happens. Everything goes fine. When I turn the key on, I got my dashboard light on. There is no messages on my ECU. All LEDs are off. And I plug my FTDI, so I got some data, garbage data, but I've got some data, so it should have worked. And really no, because I don't hear the fuel pump when I turn the key on, but it may be normal because it's quite common on race car to get the fuel circuit on a separate circuit in case of accident and so on. There is also checksum validation, but I don't really think here I messed up with the checksum. So I have no idea what's happened. So I decided to do another dump. And yeah, you know, when I make my binary, I just flash the second part of the memory. So the first part where the code should be was just empty. And that's why it did not work. You can see here the dashboard is lights up. I did not have any messages here. It's just my FTDI, which is gluing here, but I don't have any messages. And you need here to, so I need here to erase my ROM to get the right binary on it. And it's UV erasable ROM. It's quite difficult today to get some UV eraser. I did not have time to get one on the internet online, so I decided to ask some friends, electronics friends, old one too. I've done quite 10 Hacker I think, and they did not have this. I was also in a beauty institute, and I think I fear the lady. And then come a solution. None of them are gluing UV, but there is a cat toy, and this is this one, and the kind of laser one, you know, you can play with it. And it also has UV. And when I'm looking at the spec of this toy, it's the right UV to erase the ROM. So I think it should do the job. This is the current state of the project, with the UV eraser here. It has been in this configuration for 2 weeks, and I just remove almost 20% of the memory. So if someone has a UV eraser here, I'm really be happy to speak with you and finally finish this project. Because, yeah, just some errors. So what I need to do next is just flash the correct ROM. This ROM should work because all things are aligned well, I guess. My local tuner can open it, and he already has modified it to run E85. So I just need to get his dump, flash it to my EPROM, and close this project. So, did you have any question?
So you can also get E85 conversion kits that have a small computer in them that will just read the original gasoline pulses for the injectors and calculate the new one and use that to actually put the correct injection time for E85. Why didn't you just use that?
Because there are no sensors, and when you run with a custom ECU, external ECU, you need to have some sensors and also some new injectors to get it working. This is stock, and it's running stock. This is why I don't want to get an external device, and an external device can't work here. The flex fuel one can't work here in this configuration. You need to add some other peripheral to get it running.
Any more questions? That's it then. Thank you. Thanks, Gyver.
Thank you.